Hello everyone. In the last video, we studied how to convert a binary number system to a decimal number system, and we took some examples. In this video, we will learn how to convert a decimal number system to a binary number system. To convert integer number from decimal to binary, divide the number by the base 2 until the result finally becomes 0. Traverse the remainders from bottom to top to get the result in binary. Let us take an example. Convert the decimal number 52 to binary. We will make two columns, integer and a remainder. Divide 52 by the base 2 gives 26 with a remainder 0. Then divide 26 by the base 2 gives 13 with a remainder 0. Then divide 13 by 2 gives 6 with a remainder 1. Then divide 6 by 2 gives 3 with a remainder 0. Divide 3 by 2 gives 1 with a remainder 1. Divide 1 by 2 gives 0 with a remainder 1. Now traverse the remainder column from bottom to top, so the number 52 in decimal is equal to 110100 in binary. Let us take another example with decimal point. Convert the decimal number 27.15 to binary. For convenience, we will take the number as two parts, the integer part and the fractional part. Then we add the two converted parts together. First, we will convert the integer part of the number, which is 27. We will make two columns, integer and a remainder. Divide 27 by the base 2 gives 13 with a remainder 1. Then divide 13 by the base 2 gives 6 with a remainder 1. Then divide 6 by 2 gives 3 with a remainder 0. Divide 3 by 2 gives 1 with a remainder 1. Divide 1 by 2 gives 0 with a remainder 1. Traverse the remainder column from bottom to top. So the number 27 in decimal is equal to 11011 in binary. Now we will convert the fractional part of the number, which is 0.15. To convert fractional number from decimal to binary, multiply the number with 2 until the number finally becomes 0, or stop after required decimal places. Traverse the integers from top to bottom to get the result number in binary. We will make two columns, fraction and integer. Multiply the number 0.15 by the base 2 equal to 0.3, so the fractional part is 0.3 and the integer part is 0. Then multiply the number 0.3 by the base 2 equal to 0.6, so the integer part is 0 and the fractional part is 0.6. Then multiply the number 0.6 by the base 2 equal to 1.2, so the integer part is 1 and the fractional part is 0.2. Then multiply the number 0.2 by the base 2 equal to 0.4. So the integer part is 0 and the fractional part is 0.4. Then multiply the number 0.4 by the base 2 equal to 0.8. So the integer part is 0 and the fractional part is 0.8. Then multiply the number 0.8 by the base 2 equal to 1.6. So the integer part is 1 and the fractional part is 0.6. Then multiply the number 0.6 by the base 2 equal to 1.2. So the integer part is 1 and the fractional part is 0.2. Multiply the number 0.2 by the base 2 equal to 0.4. So the integer part is 0 and the fractional part is 0.4. Stopping at 8 decimal places. Traverse the integer column from top to bottom. So the number 0.15 in decimal is equal to 0.001011 in binary. Now we add the two converted parts together. The converted integer part for 27 was 11011 plus the converted fractional part is 0.001011, and this is equal to 1111.001011. So the number 27.15 in decimal is equal to 1111.001011 in binary. At the end of this video, I want to mention that we have made a great app for students to convert numbers from any base to any base and show the step-by-step solution to learn while solving. Let us take an example and solve it with the Logic Kit app. Select the input base, then select the output base. For example, let us type 376.89. As we can see, the result in binary is 10111100.11100011. Press show steps to see a good explanation and detailed step-by-step, so you can understand the solution. We made it as simple as possible to solve your homework and learn. I will leave the link to download the Logic Kit app in the description. Don't forget to subscribe to the channel, follow us on Facebook and visit our website. All links are in the description.